Hello, Dr. Boland.
Hi.
So we are now finishing the International Conference on Bioprinting and Biofabrication. What is your reaction to the Congress so far?
Oh, I'm very excited. I like the Congress. There were about 60 participants. We've heard about different methods of fabricating tissues or tissue-like structures. We've heard about biological assays that were done. And I'm very excited to see this field growing.
Very good. Could you explain what biofabrication is? And I'm going to ask a little bit more because of some of the commentaries you made during the Congress so far. You kind of insisted on the difference between biofabrication and biomanufacturing. Could you elaborate on this idea a little bit?
I like the term biofabrication better than biomanufacturing. It's just semantics, I guess, but I think biofabrication is more inclusive versus biomanufacturing might include more engineers in their work because manufacturing is an engineering term. Fabrication, as I explained in my talk, is actually something that can be found in nature and does not necessarily involve engineering, but it may include engineering. So I think the term is more inclusive, and that's why I like it.
Okay. So at this conference, during your talk, you spoke about the importance of a microvasculature within an implant. Could you explain to our listeners why this is so important?
Sure. I mean, microvasculature is what keeps our tissues alive. If you will take a scaffold, for example, without any cells, you might implant it. And typically, you would have maybe a millimeter or so per day of vasculature growing into it, which is fine and which is what many people have done. But if you are adding cells to your implant, then these cells that are inside the implant must be kept alive. And the only way of doing it is by having some kind of microvasculature, some kind of channel in there that allows the oxygen to get to the cells.
And how is your lab addressing this issue?
Well, as you know, we're doing this inkjet printing layer by layer, so we're building basically every other layer. We're building these vascular structures into our constructs.
Okay. And what kind of problems have you encountered so far in this work?
Many problems. Let me just rephrase this question. So of course, there's always problems there might be day-to-day problems. There may be problems that are longer term. But I think it's very important to discuss the new ideas and concepts with a number of people, engineers, biologists, medical doctors, in a team. Discuss it very openly, and then often your mind will open up and you will find solutions to problems.
So my original final question for you was, where do you see your labs work in 5 years' time? But what I think I'd like to ask, and I think might be more pertinent to our purposes, is where do you see tissue engineering, the field of tissue engineering in 5 years' time?
Biofabrication or tissue engineering?
Biofabrication.
Biofabrication. Okay. I think in this meeting we've seen a lot of potential applications of biofabrication in tissue engineering. I have my doubts that this will pan out the way people think about it. I think there's many other contributions biofabrication can make. And we have seen this in one talk today by the group from PISA that actually fabricates a scaffold that also acts as a sensor. And I think if we continue along those lines, we can make tools that will be immensely valuable for example, regenerative medicine, the whole field. If one, for example, could detect oxygen levels inside a scaffold through a tissue or something by the way the scaffold reacts, and maybe by adding functionality to it when it's printed or fabricated, that would be an immense advantage. Just a tool that will allow us maybe to make better tissue engineering constructs in the future.
Okay. Thank you very much, Dr. Boland.
Sure.